Hello everyone, I will be talking about biomimicry. If you recall, this was one of the first lessons we had in class, where we were assigned to select something that was engineered through biomimicry. One example that was discussed was the bullet train modeled after the kingfisher, where the kingfisher's beak was imitated to reduce the noise it would produce when it would enter a tunnel. For my reflection assignment, I will be talking about termite mounds and how an architect used them to engineer a building in Zimbabwe to reduce energy cost. In 1991, architect Mick Pierce was hired to build the country's largest office and retail building in Harare, Zimbabwe, by a group of investors. This building is now famously called the Eastgate Center. Investors hired Mick Pierce to engineer a building capable of reducing the cost of cooling. But how was he to do such a large task that was never done before? The solution was to look at what was already done in nature: termite mounds. Termite mounds can be up to 30 feet, look weird, and have many pores. They act as large lungs, breathing in cooler and fresh air, then releasing hotter, unwanted air. Such characteristics of the termite mound allowed Mick Pierce to take the termite mound model and apply it to the Eastgate Center. As we all know, this is called biomimicry. So how did he engineer the Eastgate Center? Well, first, the building is made of concrete, which is like the soil in the termite mounds, have a certain property. These materials have a high thermal mass. Otherwise, they are allowed to absorb heat without changing much temperature, which is important because the building of this scale can operate all day without heating up as much internally. As important, a second characteristic modeled after the termite mound is the internal structure of the building. Much like the tunnels and pathways that are used for ventilation and thermal dissipation in the mounds, the Eastgate building has vents built into the floors and walls to do the same. To further reduce heat gain in the day and increase the heat loss at night, the exterior of the building is prickly, much like the bumpiness of the termite mounds. The bumpiness of the structure increases the surface area where the exterior air can passively cool the building. But what are the results? Well, the building averages 82 degrees in the day and 52 degrees at night. This is good when the highest temperature can be up to 110 degrees. However, it is not to say that it is 100% efficient. Fans are used at the base of the building to assist in the building's ventilation, kinda how more holes are made in the base of the termite mounds to increase airflow into the structure. Overall, the Eastgate Center uses 30% less energy than other buildings of its size, and yeah. Now, with all this said, I believe that biomimicry is an important tool that must be used and taken into consideration when we engineer anything. After all, nature has done the hard work for us. We just need to imitate it. And that is it. I thank you guys for taking your time to listen to this video. Have a good day.